Well, hello. Let's wrap up that rigid diaphragm Excel spreadsheet that we got going on. But first, let's warm up with a little Wordle. Just get the brain going a little bit. Hope everyone's Sunday is going well so far. Let me know where you're coming in from, where you are currently engineering from, even if you're not engineering, just, where we're connecting. All right. The D's calling my name. Two D's, risky, first word. Yeah, but we're gonna go for it. Did it pay off? Maybe not. We may never know. Two E's, also crazy risky. Oh. But there are two E's now, aren't there? Oh, I got a little hot water going. I don't know, should I do tea or coffee? What are we feeling? What's everyone's go-to? Let's just try to piece together the last. Worse, but then that wouldn't leave our E. Curse. Also wouldn't do our E, but we're just kind of piecing things together. Purse. I'm trying to think. L-E-R-S-E. Is that a word? No. About blank. I'm just gonna leave that there for a hot sec. EA or AE? Alan, welcome in. So kind of did one yesterday a little bit. When am I doing another study session? They're gearing back up now. I was working on kind of a hybrid of studying a concept, rigid diaphragm, and also building a spreadsheet. So I'm wrapping that up today. But then it's going to be moving forward from there. I'm going to be getting back into midweek study sessions, maybe 2 live ones a week. Maybe 1 on the weekend and then 1 during the week, and just rolling again. So that's the plan. Oh, what can we try? It's a bad idea, but I'm just gonna try and get some placement. Oh my God. And music enters the auditorium. What's going on, music? Get in your seat. Get in your seat. So something E R something E. Interesting. Come on, let's wrap this up. Verge. Let's go. All right. A fiver, not the best in the world. But it's all right. Let's see, what do we want to swap to? All right, we got our one note up. Then I want to get my Excel up. All right, let's see. What do I want to do here? I'm going to move the touch screen gently so I don't disconnect anything. We're all over the place. All right. Swap over to the spreadsheet. Hey, I'll be back in 2 seconds. I'm just gonna grab my hot water. Back. When am I planning to take the exam? Believe it or not, I think so. I have the morning portion of the lateral exam and the afternoon portion of the lateral exam decoupled now, so I have to take 2 sessions. I'm signed up for the morning portion, and Loosely, I mean, I kind of want to take it like beginning of March, maybe first or second week in March. So that's the plan as of right now. So over this month, I'm kind of locking in and going to refresh myself on everything and rearrange my study preparation because it's computer based. That's more of the time I think I have to take is figuring out the new format. So you'll be seeing me a lot more over the course of this month. Not bad. All right, let's get after it. All right, and anyone in the chat who was here yesterday wants to let anybody new coming in here, if you're here to study and you just want to have that presence, just tell me to shut up in chat and I'll mute myself. Otherwise, there was a few people yesterday who enjoyed my open thoughts as I worked through this spreadsheet, kind of explaining myself as I moved through it, what I was getting after. Just let me know one way or another what you want and I'll make it happen, aight? Christian, welcome in. Welcome to the auditorium. How many years experience do you have now? What do I have? Been in the industry for like 8 years, something like that, which is crazy to think. Hey, Kamala T, welcome in. Sorry, I'm new. Are you studying master's or PhD? No, I'm this young, handsome face. I know, just a schoolboy. No, I have my bachelor's in civil engineering, and then my master's I already have in structural engineering. Didn't want to pursue my PhD. I really wanted to get into, I didn't want to really get into the workforce, but I wanted to get into the professional field, professional side of things. So no PhD for this guy. So yeah, been in the industry for about 8 years now. This is hopefully something that you see in front of you here. This isn't like a homework assignment. This is something that I want to be able to use in my professional career as a, one of those, like we've talked about, one of those tools in the utility belt that just helps you perform better as an engineer. No problem, Kamala. What's the typical salary for a structural engineer with 8 years? Boy, isn't that the $1 million question? It's not $1 million, unfortunately. I know, I don't want to give you a roundabout answer. It can vary, but for engineering consulting, for structural engineering consulting in the US, it will vary based on where you are. If you're in a more expensive city, the salary hopefully should be a little bit higher. For cost of living purposes, if you're in a smaller rural area, it will probably be less for that reason. For consulting purposes, not anything like specialty related, so nothing like structural engineer for a utility company, or you do something for a very specific niche system. If it's buildings, 8 years experience, probably anywhere from 90 to 120K range, I'll probably give it, in my opinion, which is kind of sad. I'm at like 105 right now. I think it's kind of where I'm at, just at baseline. Actually, I gotta write that down. I want to do an updated content for you guys on my salary history. I actually do have a much longer breakdown of my career salary history over the previous 6 years, when I think I did it 2 years ago, on my YouTube channel. So check that out if you want. Gives you a little more insight as to what I did, how I did it, how I negotiated, blah, 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 values. So check it out. Kamala's asking, am I from Finland or where did the name of the channel came from? So it is Finnish inspired. I am not from Finland. But yes, Kestava, hopefully I researched it correctly, means sustainable or sustainability in Finnish. So some of the background creating my channel, I ultimately have a huge respect for kind of Nordic culture and Nordic building style. I think it's just really cool overall. And so I wanted to put that concept of, again, quote, sustainability into the engineering that I do. Maybe not right now, maybe what I do now is kind of standard stuff, but in the future, in the far future, who knows what that may hold, I want to embody all things kind of Kestava engineering, sustainable engineering, making, and not just sustainable like in the way that we know it, but sustainable on a broader sense of looking deeper at a structure and making it perfectly imperfect for each specific job that comes up. So yeah, that's where it comes from. Which field would you say gets paid the most in the civil field? In the civil field, I have a couple of buddies, and let's see, one of them is transportation, one of them is geotechnical, and one of them is environmental. There you go. And then I'm structural. And then I have another buddy in structural. So go figure that I have a nice little pool to pick from. We're all decently similar. It'll totally depend on the type of company that you work for. But I think my transportation buddy makes the most out of all of us. I think he's like at 130K. I'd have to ask him again, but he at one point was kind of pivoting a little bit, and I'm speaking for him. So hey, if you're out there, I'm not gonna say your name, but and I say this wrong, we gotta catch up again. But he kind of drifted in the transportation part into like what do you want to call that? Like smart technologies and like doing that for transportation for what is it? ITS systems, integrated technology systems. I think he was getting more into that, which is, I don't want to say techie by any means, but I think there's more money in that type of sector within transportation engineering. So that equated to more potential financial gain. All good questions. At 80. All right, so we remembered from last time, our green is the stuff that we vetted so far. Yellow, we're keeping an eye on. And then as we move forward through the whites, we want to turn them green. Basically re-going over this whole thing. So we finished case 1, now we need to do case 2, 3, 4. Which should be easy enough because it should just be case 1 is E max, case 2 is E min. So we should make sure everything's locked in. That's right, that's our direct, so we don't use our eccentricity. Hey! Rajan, welcome in. Fan of your funny YouTube shorts. Hey, let's go! someone calling out the shorts. It's the fun little thing that I do on the side that I think just hopefully everyone gets is lighthearted and fun. Hey, glad you popped into the auditorium. Oh, Ryan popping in. Hey, what's going on, Ryan? Sweet spreadsheet? Yeah, you know, we're putting a little something together. Troubleshooting here. Not trying to make the world's perfect, all-encompassing, rigid diaphragm analysis, but trying to make something simple here that kind of works out. But it was giving me a couple of problems, and I'm fixing it up. So going through it from start to finish, trying to make sure all the direction of all of my shear to each of the vertical lateral elements is properly being analyzed in the right direction. But we'll see. We'll see if it all works out. Welcome in, Ryan. You want to talk about an absolutely dominant structural engineer? Ryan's the guy to go to. He's awesome. He's taught me a lot. All right, so case 2. It is literally the same thing. I should be able to take these, so I'm gonna just copy this over, but then I need to make sure that... Oh, did everything stay put? That would be great if it did. Oh, nice, I do have everything flagged correctly. So this should be the same. And then good. And then the only thing we have to switch is our minimum. Good. And then just the sum, that can come over as well. Good. Should be able to flag these, bring them down. Uh-oh, something's not running right. What happened here? Do have 2 of them. Move both of them over. I need to be careful here because I thought last time I could combine both my X and Y together because I'm only analyzing like wall lines that are not at angles. I think that should still work. I just need to bring this down. Oh, it doesn't work anymore. Is it not? So it's probably doing this, right? That should get you this. Oh, it doesn't. So I guess we do want to keep it just as it is. So we're gonna scrap this. Okay. Hey, we got auditorium starting to fill up. Love everybody coming in. Remember, if you want that cushy red, plush seat in the front row that you see is reserved, hey, all you gotta do is subscribe and you get your very own seat. Don't even gotta be a member, don't gotta do anything, don't gotta pay anything, just gotta subscribe, be a part of the team. So if you want that reservation, if you want your nice upgraded seat in the front so you don't gotta squint, consider subscribing. And we're tracking. So I'll frickin' know. But if you don't feel like it, I get it. Everyone's trying to get your attention nowadays, so don't sweat it. All right, so we know, does that cause a problem? I don't think so, because I already designate X direction and Y direction, so I'll be all right. So then I just want to do what I just did. I'm going to take these, copy them, paste them, but then instead of max, we have now the min. We'll drag these down. There, and now we're flagged correctly. Summation of our story shear in that direction is equal to, so we're good. And so if there's a slight difference in our load distribution, very, very slight, but that's because our accidental torsion is low. But like if we were to jack it up, I guess it still doesn't make a huge difference because, okay. This case 1, let's remember case 1. This is case 1. Oh, can you see that? Now you can. All right, so direct shear 1 and 4 should be taken huge numbers, except 1 is not a lot of stiffness in comparison to 4, 2,500. So 1 is basically going to see nothing in direct shear. Yeah. Okay, our torsion is happening, so it's going to... Yeah, we have this going on up here. So shear wall 4 is direct is additive and torsional is subtracting for shear wall 4, which that's spot on, and then it's add for that. That works. Okay. And then the only thing for case 2 is we're switching this out for E min. Okay. Curious. Kind of curious. If wall line 1 goes to 1, oh no. That's not right. Oh, there are values there. See, but I have a problem with that because I feel like all of my walls should be engaging here, at least from the torsional effects. Or I guess. Because at this point, now there's no wall. So walls 3 and 5 should be seeing some torsional shear. And they should be seeing it in the y direction. That's where I'm like, plus parenthesis, all of this, close parenthesis, except this is going to be H. And this is going to be K. Oh, because those are equal and opposite. Oh, because that balances, so that works. That works now. Oh, so torsion is both directions I should be doing. But direct, I should only be in the direction of my load. I think that works now. So now if we go back to 100, still 96. Now that nice. and 4 is the... Okay. Okay. Jack, hey, welcome in. Tuning in late, it's all right. You're never late. Did you mention where your sample questions are from? Did you make the spreadsheet? So I've been building this spreadsheet. I started with one that I didn't think was quite doing things the right way, and so I've been building off of this. I think I'm almost there, but we'll see. I know the results that I'm looking for, but yeah, I was working on this last night, and I'm hoping to wrap it up today in this session. But the example is, oh shoot, you guys aren't even looking at this right now, sorry. This is my problem that I have. So yeah, that's the dealio. I know, there's a lot going on there. I'm kind of just working through this at my own pace. I want to get this locked in for me, and then obviously if people have interest to this, I'll do my best to relay it to you and the things that I've done. I was blabbering this whole time and you guys couldn't even see the spreadsheet. All right, so I think that's working now. So now I want to do this. Yes, and that works. Take these, let's bring their, whoops. Do that, good. Some of these, good, 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 good. Oh, except we want to do this and this. Now we want to bring, oops, now we want to bring this down. Yes. And for anyone from last time, like if I switch this, if the summation of these loads don't equate to the total story shear in the direction that we're analyzing, then we have a problem. So I have this little conditional formatting set up. So if that flares up, we can visually see that there's an error, but we're locked and loaded right now, so that's good. All right, case 1 and case 2 are done in my opinion. Let's green them up. All right, now we're moving into shear in the Y direction. Very good, very good. All right. Oh, and I can take these, paste them over. So VD, direct shear, VT, torsional shear contribution to our vertical lateral elements. Hey, Kevin, welcome in. Have I seen a slowdown in work in the Northwest area? I'm really busy at the moment, but I think there's a little bit of a slowdown. I think there's something there. Why, how about you? What's going on? Why do you ask? And hey, welcome in. All right. Case 3. Case 3, we're gonna do this, but now it's dependent upon our Y direction times our Y component over our total. I'm gonna shoot that down. Bing, bing. Yes, because we have 3 and 5 are in our Y direction. So that's good. or sorry, 3 and 5 are vertical lateral elements oriented in our X direction. It's kind of hard to say. It is oriented in the Y direction. 2 also is, I know that, but 2 I've neglected at the moment, but let's try it. If we do give a stiffness to 2, then it kicks in. So that's good. So that means we're working. And then we see in our other cases, we do start to engage it. So that's good as well. It's almost in the middle, and it's a wood wall, so it's not really doing anything for this analysis. I spoke last time, I'm enveloping this full analysis because this is a mass timber diaphragm, so it's semi-rigid technically. So you could run an analysis with computer software, but I'm kind of brute forcing it here. So I'm running a rigid diaphragm analysis as well as a flexible diaphragm analysis, and then enveloping both of those and designing for worst case, taking both designs into account. So one way to sort of get around that. So the wood walls, because they are very flexible in the rigid analysis, they're going to show that they don't have a lot of load going to them. They're not contributing to the overall stability or they're not being used for that analysis. But in the flexible case, they are going to be seeing their fair share of load, and that's going to be the controlling case that we use to design those walls. So in this case, you can actually neglect them if you want to, because they may suck up a little bit of load, but it's slightly conservative to say, well, we can ignore them in this case, and all of the load will be resisted by our masonry shear walls in this case. Currently working at DCI, seen a slowdown as a company as a whole throughout the country. Just wondering if firms were similar. Yeah, I mean, it's not like we're like overflowing, but we've taken like a breath is what I'll say. So that's really interesting. That's good info. Hopefully we get things back on track. Keep the world moving, keep people building. All right. So where were we? Y. It's X and X. Y. Because V direct. Yeah. Okay. Good. So did we? Okay, we did. Good. I'm gonna go back and flag this. I'm gonna get rid of 2 for now. That's fine. You know what? That's fine. Just help me track better. All right, we're gonna bring this over. Boom. But, okay, so we have our maxes, which are good, although this needs to be X max now. J is the same, Y. We need to go that. I think we need to go this. Maybe? Or did those just stay there? It's VY times EX gets you your T times R times RX over J. I think I could have left those. That's negative 1.4. Let's test out the theory. Let's do that again. And then let's just move these. Yeah, it's the same thing. Okay. Let's drag that down. Good. Three and 5 are getting equal and opposite. Is that true? One's getting a little bit. 2's getting a little bit. 1 and 4, because they're this. Why are 1 and 4 constantly equal and opposite? Are they? Yeah, they're identical. Let's take our tracker. Oh, got this. Bring that over. That down. Why are you flaring up? 13.6. It's spot on. What are we? Oh. This is correct, but this is the type parameter needs to change, or conditional format needs to change. Manage rule. This one is a new rule. It's not equal to that. Then we're gonna hit it with the border. The red border. Bang. Okay. This one. I guess I could have just. Shoot. Let's see. Oh, no, cancel. Shoot. Come on. Cell value greater than equal to. No, I was right. There we go. So now if this changes. Yeah. Okay. That's good. Does this make sense, though, is the question now. Let's see. Let's go back over. All right, so now our loads here, FY. Eccentricity. Okay, our torsion's going that way, which is counterclockwise, so now that's a positive torsion. Or sorry, that's a, oh shit. That's a negative torsion. yeah. We're all right. So directional, let's see, we'll go black. Directional is going to be VD. I know that technically shear wall 2 is right here, but I'm ignoring it for right now. Let's just ignore it for right now. That's 0 stiffness. Okay. Okay. So that's those. Straightforward. That would mean that it's dumping VT so that's negative. Everything else is positive. VT is negative. VT is positive. All right, so we should be seeing let's see, positive for 3 and 5. That's correct, and they're big numbers. Yep. VT. Why are you? Oh, let me swap over. True dat. Thanks, Noah. Three is positive, 5 is negative. Yep. Still don't love why these equal one another. Oh, shoot. What's going on here? EX, EY, we said is the distance from center of mass to the center of rotation. No, we have this set up so it's to the center, from the center of rotation to the center of mass, which creates a positive number. Shoot. So is this technically absolute? I hate putting absolute in this. Technically, this needs to be. And now these are reversed again. Okay. So I'm gonna flag this is yellow. I need to think about those. These are fine. Those I get. That's okay. Now, you should be seeing that and that. Just adding to it. Five should be a negative. Oh! 3 should be additive. Why are we backwards? Oh, let me see. Yeah, Kevin, that's something I gotta figure out of like, this is something kind of new of I want to start sharing things that I have / use / create. I just need to think about it and be careful of like what that entails. Like I don't want to be saying that this does something and then it doesn't do something. Like this is just me messing around. So if you send me an email, yeah, I could send it to you direct, totally. Unless I'm like tripping? Not tripping? Should be. Oh, I already got it. It's gonna be minus plus. V1 is plus, V2 doesn't exist, V3 is minus, V4 is minus, V5 is plus. Okay, so that works like that. Those are working. Why are you not working? One should be plus. It's good. Okay. All right. So 1 is plus. 2 is 0. 3 is plus, but it's minus right now. Why is this minus? Oh, because my Rx is minus. Revin CE, welcome in. Grab your seat, grab a little popcorn. I'm just gonna do this, just so I remember. So plus, just nothing. 3 should be plus. 4 should be minus. 5 should be plus. Okay. Like, so, yeah. Go back to this. Hey, Revin, I appreciate it. Thank you. Why does it freak everything out? Why does that freak everything out? When shear works so well in that direction. Oh, it's because... No? That works. It's a negative positive there. I'm gonna have to do the same thing over here. Hey! Harry, welcome in. You just got your brand new seat in the auditorium. And, ooh, we're moving. I appreciate it. All right, I'm stalling here, I know, gang. One of my problems is I feel like I should be utilizing that clockwise is negative, which means that this should be a negative number, which means that should be a negative number. So it should be taken from that, which means that these also are reversed. I mean, it would just mean reversing everything. Joey, welcome in. Joey Falcon, that's a sick name. Did I ever consider bridge design instead of buildings at any point in my career? Actually, my whole life as a kid, that's where my love of structural engineering came from. Is I thought bridges were the coolest things in the world. I like messed around and tried to build little bridges over, rivers and stuff all the time. I always loved being in a car driving over big bridges, any type of bridge really, but like bigger bridges obviously were way cooler. So that's where it all stemmed from. And then actually, unfortunately, in college, I took a bridge engineering class, and it was so chaotic that it just kind of shell shocked me into being like, whoa, I don't want anything to do with bridges. So I unfortunately lost my flavor for them, and that's where I decided, from that point on, I'm not going to look to do bridge design. That's not to say that I don't love building design. I really just as much love skyscrapers, tall buildings. Like, I always had a passion for that as well. So, and I have worked on some bridge stuff here and there. Nothing major by any means, but now that I'm a little more open-minded to learning things, not being scared of things, I would love to get involved with a bridge design one day. So, yeah. I'm gonna screenshot this. Let's see. Okay, let's put that guy right there. Rebin, yeah, absolutely, contact. Faux show. All right, so we're gonna do distance from from CM to CR for little r. Would mean it would be, we're going down, so it would be negative. Okay, reverse. Out of there. Oh, was that my only problem? And we'll figure it out in a sec. So in that case, so it's negative, so it's CM. Center of mass, so it should be minus center of mass. Minus center of mass. Center of rotation. Interesting. It's a bigger number. problem. Okay, those work. I gotta swap these. I don't know if you guys can see me at the moment, but you can just hang on for 1 second. Just gotta keep train of thought lined up as I shuffle all this. 6, 5, 6, 11. Okay, so that all works again. And now, okay. Close that. Swap over. You're currently in your first year of work out of school and work at a firm that allows me to do both. However, not sure if I would benefit from focusing one or the other. No, I was at a firm that did both. So if you have the opportunity to get exposure to each of those types of designs, I'd say that's a great starting point, as long as you obviously like the company. Having a portfolio that encompasses both, it isn't rare, but it's not common either. So to have the ability to say, hey, I want to work on a bridge, or I want to work on a building, and then you talking to your principal or your project manager and them being able to supply you one is pretty clutch, because you'll learn more quickly, because you don't have to wait for a project to arise. It could be years down the road to get your chance to work on it. So yeah, I think that's good. All right, now we're rolling a little bit here. I'll zoom in. I don't know if anyone can see all right. Okay. Now my clockwise is accurate. It's negative as we're doing clockwise. My problem is these aren't, my eccentricities are, I'm gonna go actually red. Let's fill them in red. These are not great because I had to swap them based on, to make them work to get the correct things, which isn't good, because if these center rigidities and center of mass switch orientation between one another or relative to one another, it's gonna create an error in my spreadsheet. Hey, Rebin, check out my YouTube channel. You'll see, I think, like an information tab in the ribbon. You can click on that, and then there's a contact email that you can reach me at. All right, so I think I could do this. We could do like an if statement. If YG is greater than YR, then you're gonna do what we did here. Otherwise, you're gonna do, so if it's less than, you're gonna do this minus this. Does that make sense? So if this is greater than this, then it's going to be this minus this, which gets you a negative number, so that's good. But if YG drops below YR, so if your center of mass drops, I'm drawing over here to the side, sorry. If that drops below, CM is less than CR, then that's going to create a counterclockwise torsion, so that's positive. So we want our E to be positive. So then it's going to be, so if this gets less than YR, No, that should still work. Then it's still the same thing. So it would be like if this was 10, like here, we know this won't work because if this goes to 10, it's still going to be a negative number, which doesn't work. Drops below. Then it can still just be, I don't have to be fancy with this. Because if this was 10, then it'd be positive. Yeah. Okay, so that one works. Hey, Mohammed, welcome in. Hey, I appreciate that, Mohammed. That's awesome. Over there in Toronto. How's Toronto? Cold this time of year? I've been to the city once. It was really cool. Hoping you're liking it over there. I'm glad the videos help. Hopefully they continue to help. As I learn things, I'll try to communicate them to all of you. All right, so that works. So why would this not work? Is it just the opposite? Is that all that would matter? So right now, this is creating positive, so. And then it would just be if XG gets bigger than CR, so that becomes 120, then it would be positive. Should be true. Oh, so it is. It's just a flip of these. All right, these are fine. These are fine. That's all it took. And then these are still cooking then. Okay. I think, and let's just double confirm. Hey, loving the love. Thanks, everybody. Just confirm. I took a snip of my old... my old values just to make sure I didn't want to lose track. So we are... I'm just checking these out. And see, as you can see, it used to be positive, but that wasn't indicative of the direction of the torsion. So positive or clockwise should be negative, counterclockwise should be positive, or should be positive. Yes. So now that's running right, but I fixed everything and it still gets you the same answers, at least for the first cases, and I just need to figure out the other cases. Hopefully it fixed everything. So those are good. Okay, get this out of here. So with that being done, positive, negative, positive. What is going on with this one? Oh, no. All right, so these clear. 2, 3. 3 we said should be. It should be plus plus. Let's see why not. All right, so 3. Okay. Oops. Oh, yeah. I freaking confused myself here. Reel it in. Yes. Get rid of this one. X is that. Good. And this one is that. And is our X, our Y. Yes. Should these be the opposite? Is this where my problem lies? T1 is positive. That's negative times a negative. Gets you a positive, which works. So then why did it not work down here? Is it a coincidence? Zero didn't matter. That's why. I think this is where my loophole is, and I can see how I need to repair it, but it would take some overhaul. Fuck. Oh, that's why. 5 should be... Oh, I totally made a mistake. 5 should be negative. 3 should be positive. Shoot, so way back here. This isn't right. No, man. Shoot. we could do positive throughout. That's correct, but this can't possibly function right now, right? Big nasty. I totally hate doing that, man. That's what I'm not looking forward to, having to go electronic for the SC as well. I'm retaking the lateral exam probably in like a month and a half, or the first part of now the lateral exam, and then in mid-April I'll take the second half of it. All right, that is working for now, but man, I might have to do absolutes and then have to manually do another step to confirm direction of the torsional shear. That sucks. So we can take these now. Actually, we can take these now, right? But then change this to this, change this to this, change this to this. Run that down. And change this to this, this to this. Those can remain, I believe. That's the only change that needs to be made. Yeah, okay. Close. So this is one. It should flare up. Yep. Okay. Does that make sense? Yeah, I think that makes sense. One's gonna see a little, nothing there. 3. Three's gonna see a lot. Yeah, these are unchanged. It's just the torsion that switches. Okay. Okay. And then you just want the max of that, comma that, comma that, comma that. There you go. Okay, I'm gonna hit a save on this. So what I'm doing at the end here is taking my Vmax, so it is the governing of each of the 4 cases for each shear wall. And then I will design my shear wall for that max shear. But that's as far as I'm gonna take that, but I need to keep these 4 blue cases separate because then I need to use them independently to check my diaphragm deflection so I can check my irregularity. All right, I'll be right back. Take a quick break, grab some water, do what you gotta do. voila. Hey everybody, unfortunately I had something pop up, so I'm gonna have to step away. So I'm gonna be gone for a little bit, so I'm gonna shut the stream down. I know I just kind of took a quick break there and now I'm coming back with the bad news, but it's okay. We're just gonna kick it back up again next time. So, hey, if you're new here and you like the vibe of what's going on or any of my other content that you see on my channel, consider subscribing so you get updated with all the good new stuff and what's going on the channel. If you like today's stream, give it a like before you go. You don't have to though, it's okay. But I appreciate every single one of you being in here today, learning a little bit, kind of cruising with me through this rigid diaphragm spreadsheet. I think I'm close to getting the bugs worked out, although I think I discovered where my error finally occurred. So I might have to rebuild some stuff, maybe in the shadows, maybe not. But that'll be for next time. So good luck on your studies, good luck on whatever you have to be doing out there. And I'll see you in the next one. Peace.